All right, hello everybody, this is Ms. Piekarski. We are going over the Unit 6 review, essentially everything that we've covered this 9 weeks will be on the test. So there's quite a bit, so please pay attention and take notes. It will help you to have the formulas written down, not necessarily just copying down all the problems that I have in the review. The test will consist of 15 questions. The review has a lot more than 15 questions because there's always lots of different versions of the test, and I want you to be able to answer all of the different versions of the questions. Okay, so essentially the first question, you'll have a degree and you'll have to convert it into radians, and hopefully you guys remember that to convert a degree into radians is whatever number of degree you get, you're going to multiply that by pi and then divide by 180. And I always like exact answers if you can give them to me. So for 340 degrees, you would multiply that by pi, divide by 180. You would need to reduce your fraction and just leave the pi as part of the answer. So 340 divided by 180 reduces to 17/9. Make sure you include the pi there. Okay. If your angle was 186 degrees, again, just set up your fraction and then reduce it. So 186 divided by 180 reduces to 31/30. And then if your degree was 265, multiply it by pi, divide by 180, reduce your fraction. So 265 divided by 180 would be 53/36. Okay. Hopefully that's an easy question for you guys. You will also be given some radians, and you'll have to figure out you'll have to convert them to degrees. So you might want to include on your card that to convert from radians to degrees, whatever your radian value is, you're going to multiply by 180 and divide by pi. Most of the time, your radians, you'll already have the pi symbol in the numerator, so really the pi's just cancel out. Then all you have to do is simplify your fractions. And with degrees, you want to just round to one decimal place if you have a decimal. In these examples, I don't think any of them end up giving you decimals. Let me see. Yeah, all of these should give you whole number answers. So no matter what your radians will look like, you should be able to find or convert it into degrees. You multiply by 180 and divide by pi. Okay, those are your easy questions. Now this one's a little bit harder. So we have a diagram below. You have two sidings of the top of a flagpole, and they're taken 75 meters apart on ground level. The two sidings are 21 degrees, so this angle here is 21 degrees. And this angle here is 32 degrees. What is the height of the flagpole? And then the distance here is 75, and we are looking for this measurement here. Okay, notice that this angle, this triangle here is a right triangle, but this one is not a right triangle. Okay, we need extra space for this, so I'm going to show you how to set it up first on this page. And first thing that you want to do, because we know that this angle is 32 degrees, we're going to find this angle. And these two angles will be supplementary, so you do 180 minus 32 degrees and you get 148 degrees. And then once you know that this angle is 148 degrees, you can add it to 21 degrees, subtract that, your answer from 180 to get your angle that's up here. In this case, the angle is 11 degrees. Okay, and then we now need to find the measurement of this side length here. Okay, because we know this side measurement and this angle now, we can use the law of sines. We have an angle and its coordinating side measurement. So we'll use that ratio, 75 over sine 11. We want to find this side measurement, so we're going to do x over sine 21. You're going to cross multiply and divide. You end up getting your x, or actually I think I labeled that h. So this measurement here would equal this. You plug that into the calculator and you get your answer. Now, if you stop there, you might find this answer choice as one of your answers in the multiple choice test, but it's going to be the wrong answer because we're not looking for this length here. We're looking for the length of the flagpole here. So, but now that we have that, we can use our trig ratios to find this measurement here. So we know that h is 140.861 meters, okay? And we want to find the opposite side. We have this side angle here, so we are going to use the we're going to use the sine ratio. So sine of 32 degrees will equal the length of the flagpole divided by the hypotenuse, because if you notice on this right triangle, this is our hypotenuse. And we multiply both sides by 140.86. We plug that all in the calculator, and the calculator tells us it's 74.6 meters high. Okay. Now with this one, there's two different versions. Actually, no, I guess there's 4 or 5 different versions of the test. Some of them, you'll have this triangle here. Notice we do have a right triangle, and some of the tests want you to find this angle here, okay? And they give you this side measurement and this side measurement. Again, with this, you're going to use your trig ratios because you're looking for this angle, and you know your adjacent side and your hypotenuse. You're going to do your cosine x equals the adjacent over the hypotenuse. Okay, so this time it's cosine A because we labeled this angle A, and it's going to be equal, cosine A will equal 11.6 divided by 18.4. Okay, anytime we look for an angle measurement, you have to do inverse. So it would be inverse cosine of our fraction, and then we plug that all into the calculator, and then the calculator will give us our answer of 50.9 degrees. Okay. Some versions of the test will have the same kind of setup. Notice your angles are set up, or your triangles measurements are set up the same, but some of them you'll want to find angle B that's over here, and you have this side measurement and this side measurement. So instead of using your cosine trig ratio, you're going to use your sine trig ratio. So you'll have sine B equals 11.6 divided by 18.6. Okay. Make sure you remember how to set up your SOHCAHTOA. The tangent is x equals opposite over adjacent, sine x equals opposite over hypotenuse, and then cosine x equals adjacent over hypotenuse. This time we're doing the opposite over the hypotenuse. Okay, and then to find angle B, you need to do the inverse sine, and then you plug everything into your calculator, and you get your angle in degrees. Okay, so guys, there's two different versions of there's two different possibilities there. Some of you will have a triangle where you have the adjacent and the hypotenuse. Some of you will have a triangle where you have the opposite and the hypotenuse. Some of you might have a triangle where you have the opposite and the adjacent, and you have to use your tangent ratio. Okay, make sure you remember how to do those. Here's one that we haven't done a lot with in class, but we've gone over the formulas and we've gone over some problems out of the textbook, but not necessarily any application problems. Okay, so all this is, it's an application problem where we need to find the secant, or the sector length, okay, or excuse me, arc length of, in this case, we're applying it to the shape of the earth. It's round, and we're going to pretend it's a perfect circle, and that the radius of the earth is 4,000 miles. And we have latitude and longitude. If any of you guys have ever been in ROTC where you've taken a compass course, or if you've ever done geocaching, you know what latitude and longitude lines are. Essentially, they're just radiuses of the earth starting at the equator. And in this case, I want to find the distance from Austin to Wichita. And these are the degrees of the angle, okay, starting at the equator. So from the equator, it's 30.27 degrees to Austin, and then starting at the equator to Wichita, it's 37.69. So in this case, we want to know what is the approximate distance between the two cities. What we're looking for is this distance right here, okay? So I don't care how far it is from the equator to Austin or from the equator to Wichita. I just want to know this distance between the two cities. So I need to find this angle. Okay, this question is going to take a little bit of space. So let's move everything up. So now to find the approximate distance, first to find the angle, you're going to take Wichita's angle, subtract it from Austin's angle, and then you find your angle in degrees of what you need to find this, okay? So this angle right here is 7.42 degrees. Now don't forget your arc length formulas you have to have your angle in radians, so you have to convert from degrees to radians. Okay, when you do all that, it's fine if you go ahead and put it in the calculator, especially since we already have a decimal here. You get this answer for your radians. Now the formula to find your arc length is the angle times the radius. So it's a really easy equation as long as you remember you cannot use degrees, you have to use radians here. Okay, so it's your angle in radians times the radius, and you get the distance from Austin to Wichita is 518 miles. Okay, in that one we're just looking for the arc length. Okay, this time we're looking for the area of a sector of a circle. Okay, in this case we have 3 friends order a 16-inch pizza to share. Sarah eats only 4 degrees of a slice of pizza. How many square inches is this? So the diameter is 16. You know what, now that I caught that, I wonder if I used 16 in my formula or if I used 8. Let's see. Yep, I did use 8. Okay. So the diameter is 16. Don't forget in the equation you need the radius. So, and we also need to change from degrees to radians. So 40 degrees, multiply that by pi, divide by 180. That will reduce really nicely to 2 pi over 9. Okay, to find the area of a sector, it's 1/2 times the radius squared times your angle in radians. Okay, so that's how you set it up. Plug everything into the calculator, push enter. The calculator tells you it's 22.34 inches squared. Let's see this one. Let's see, how many possible triangles can you create if angle A is 20 degrees, side A is 2 centimeters, and side B is 6.5 centimeters? So in order to answer this question, you first have to assume that you can make 2 triangles, and you need to find B1 and find B2, and then analyze those questions or angles and see if it will actually work. Okay, this time I'm not going to draw a diagram for you. I'm just going to set up the equation. So I'd set it up as 2 over sine 20 equals 6.5 over sine B, and I'm looking for B, my B value. So I cross multiply and divide. I get I do the inverse sine function of this fraction, and I plug everything in the calculator. And if the calculator gives me the term undefined, I can go back and make sure I set it up right. If I did set everything up correctly, then the reason why it's undefined is because I cannot make a triangle with these measurements here. Okay. Some of you guys might have the test where the answer is going to be undefined or no triangles. Okay. Now, same situation, but we have different numbers. We're still going to set it up the same. Do 4 because that's our side, we use 4 because that's our side measurement for A, over sine 60 degrees, set it equal to 3.5 over sine B. We cross multiply and divide. We do inverse sine of our fraction, and we get an angle. So we know we can have at least one triangle with this one. And then to find out the other, figure out what the other angle is, we're going to do 180 minus our answer up here, and we get 130.7 degrees. Now to see if this will work, we're going to add it to our angle A up here. So 130 plus 60 is 190 degrees. So we know that this does not work. In this case, we only have one possible triangle. Okay. Again, same process. Our numbers are changed a little bit. So any of you that try to cheat off of each other and you glance at somebody else's paper and you see and you notice that, oh, they have the same basic question, pay attention because most likely their numbers are going to be wrong, different. Okay. And then in this case, same process, set it all up, cross multiply and divide, do the inverse, you get 90 degrees. Find your other angle, you get 121, and then check and verify. If you have, let's see, 121 plus 40 gives you 161, so that triangle will work. So in this case, this one you have two different triangles. Okay, whoops, I skipped one. All right, convert the revolutions per minute into angular velocity in radians per second. This one, there's 2 pi radians in each revolution. So you're first going to multiply by 2 pi, and you get the revolutions in, or excuse me, you get your angular velocity in radians per minute. But then to convert from minutes to, then we want radians per second. So to get rid of the minutes, we have to divide by 60 to get rid of the minutes. And then we plug everything in our calculator. Most of the time on the test, you will be able to get a simplified answer like this. Okay, if you can simplify, I want you to go ahead and do so. Okay, so 30 pi divided by 60 reduces to pi over 3. This one, same process, you just have a different number. So you have 270 times 2 divided by 60. And this one, I think you just get whole numbers. Yeah, you get 9 pi. And that'll be radians per second. And then here's another one, just a different number, 35 revolutions per minute. Multiply it by 2 pi divided by 60. Okay, simplify your fraction. In this case, we get 7 pi over 6 radians per second. So this is how we find our angular velocity if we're given the measurement or the speed in revolutions per minute. And most of the time you get them in revolutions per minute. So now once we get those angular velocities, you'll have, the question will say, if the radius of the pulley is 37 inches, what would the linear velocity be for each of the angular velocities from the previous question? Okay, so to convert from angular to linear velocity, you multiply by 37 and you just plug it in the calculator and you get your answer. Doesn't matter what your angular velocity is, you can just multiply it by the radius. It's a super easy formula again. Just make sure you have it, your angular velocity in radians per time, not revolutions per time. Okay? This part is really easy. You just plug it, multiply your previous answer by 37, and you're good to go. All right, here's another question. Find the area of the triangle. You have the formulas for this. Anytime you're looking for the area, notice I have all 3 side measurements. So you be very careful. Make sure that you are going to use the correct side measurements. So whatever angle you have, you just use the side measurement that is on either side of that angle. Okay. So in this case, we have 27, and we're going to use 10, or it'll be 1/2 times 10 times 21.8 times sine of 127. You just plug that whole thing in the calculator, and you get your answer. Okay. Again, you'll have lots of different versions on this. Sometimes the angle will be over here that you have, and you'll have to use these two sides. Okay. Yep. All right, now our special triangles. We are going to start with finding side D here. When we have when we have the hypotenuse, and this is D is our short side, all you have to do is divide by 2 to find the short side when you have the hypotenuse. Now, once you have the short side, to find the long leg, you have to multiply by the square root of 3. Okay? That one's pretty easy, but if you have the long leg and you're looking for the short leg, you have to divide by the square root of 3. Okay, you cannot leave the radical in the denominator, so you multiply both numerator and denominator by square root of 3, and then you simplify it if you can. Now this one you can't simplify. That's as simplified as you can get it. I don't want rounded answers. Okay, now that we have our short leg here, we want to find the hypotenuse, so we're just going to multiply this number by 2, and we end up with 28 times the square root of 3 over 3. Next, possible questions, you have another special right triangles, except for this one, it's 45, 45, 90. If you have the hypotenuse and you're looking for your side measurements, you need to divide by square root of 2. When you do that, you have to multiply numerator and denominator by the square root of 2, simplify, and reduce your answer. Once you know side A, it's super easy to find side B. It's exactly the same thing. Okay, same thing down here. If you know this measurement, then we already know that D is 14. If your leg is given and you have to find your hypotenuse, then you're going to divide by the square root of 2, and you have all your answers there. Alrighty. On this one, you have 3 side measurements, and you need to find the smallest angle. The biggest thing is make sure you know which one is the smallest angle. In this case, this is the smallest side, so the opposite angle is the smallest angle. So we're looking for this angle here. When you do that, and we are going to have to use the law of cosine because we do not have any other angles. So our 11 squared is going to be on the left side, and everything else is going to be on the right. Okay, from this point we are looking for our angle, so we'll have cosine theta over here. We can simplify everything by squaring it and multiplying everything that can be multiplied. Okay, at this point we need to subtract by 845.01. Okay, and then we're going to divide, and then if you feel like it, you can plug that into the calculator and get an answer. But that'll just equal to cosine theta. In order to find out what your angle is, you have to do inverse cosine of whatever you got here, and then your calculator will give you an answer. Okay, so that's if you're looking for the smallest angle. If you're looking for the largest angle, it's going to be, we're looking for this, we have this side measurement is the longest side, so the largest angle is going to be here. We're looking for this angle. The whole process is going to be exactly the same as what we did last time. Our 21 is going to be on the left side because that's the opposite side measurement. Everything else will go on the right. We'll simplify, we'll subtract, we'll divide, we'll calculate it if we feel like it, and then we'll do inverse cosine of whatever we calculated. Okay? And then, let's see. If we're looking for the middle angle, the angle that's neither the smallest nor the largest, okay? So here's our middle side value. This will be our middle angle. And so 20.1 is going to be on the left side of our the equal sign. Everything else is on the right. We simplify, we subtract, we divide, we do calculate it if we feel like it, and then we do the inverse cosine, and we get our angle. Okay. With this one, I think this is the final question on the review. You have 3 different side values. We also have an angle value, and some tests it'll say find angle A, some tests will say find angle B. Just depends on which test you get. No matter what, you should be able to set up your ratios correctly. Okay, so if you just have to find angle B, then you would use the 26.1 divided by sine 100. Okay, and granted, guys, I do know that yes, you can use the law of cosine with this, but it'll be much faster and much easier if you use the law of sine. Excuse me. So we're going to just use law of sine. So this is what the fraction is because we have these 2 measurements. And then to find sine B, it would be 18.1 over sine B. If we wanted to find A, this fraction will be exactly the same. It would just be 16 over sine A because 16 is opposite side of side A. Okay, then we would cross multiply and divide. Okay, and then to find our angles, we would do inverse sine of the fractions and we get our angles. Now, if you are paying attention, you'll probably notice that if you add 100 plus 37.1 plus 43.1 in this triangle, it is actually a little bit more than 180. The reason why is when I set up this picture in my calculator, the calculator rounded this angle. So they might have rounded down, they might have rounded up, but because this angle is rounded, these angle measurements are off a little bit. I believe I did the same thing with the test. So if your answers are, like, let's say you're looking for angle B and your answer is 48.7 and the only answer choice is 43.1, then just pick the answer choice that's closest to your answer. Because notice that these 2 angles are pretty far apart. Like if you got a 42.1 and your choices were 43 or 20 or 39, I would suggest you pick the 43. Okay. All right. I hope this review was helpful. Fill in your index card. Be ready for the test on Friday.